so what we're going to do right now is take notes for section 7.3, proving that quadrilaterals are parallelograms. What's nice about this is we're not learning anything new. We're just practicing the skills from section 7.2. So, do you have an understanding of telling when a quadrilateral is a parallelogram? Are you able to write equations and find missing measures based on the 4 rules? And then you'll have 3 assignments. But again, nothing new. We were just practicing the concepts that we learned yesterday and adding in some new types of problems. Okay, so let's just review the 4 rules. Rule number 1 is that opposite sides are congruent. So that means if the left is 5, the right is 5. If the top is 10, the bottom is 10. The next one says that opposite angles are congruent. So if this one on the top right is 120, this one down here on the top left is 120, the bottom right is 120. The next one was that adjacent angles are supplementary. Again, that's 180. So if I say that this one's 70, then this one has to be 110 because they're next to each other and they have to equal 180. The last rule is that diagonals bisect each other. Okay? So we cut them in half, and so I know that this diagonal is equal to that part of the diagonal, and then the other one's the same also. Okay? So we're using those basic 4 rules. You're going to have problems that say state the theorem, but stating the theorem, I'm not requiring that. I'm just making you state the rule that it is. Okay? So here's some examples. The first set says state the theorem, which I'm wanting the rule that says the quadrilateral is a parallelogram. Well, if I look at A tells me that 13 is equal to 13 and 8 is equal to 8. What rule says that? That's right. It's rule number 1. Opposite sides are congruent. Now, I don't want you to write rule 1. I want you to write this because I'm allowing you not to explain the theorems, but I do want you to write those 4 words. Okay? For the second one, why do I know that this is a parallelogram based on these? Well, those are adjacent angles, and those 2 add up to 180. So you can say adjacent angles equal 180, and that's why it's a parallelogram, because that's true. That's rule number 4. Or no, rule number 3, sorry. And then part C, this is saying that my diagonals, I forgot to put the tick marks like your book had, that the diagonals are equal. Well, this one's equal to this one, and 5 definitely equals 5. So this is that the diagonals bisect. So that's rule number 4. So when it's saying state the theorem, it's just really asking you the rules, and you can write it out in words. I'm not asking for names or numbers. Okay, so let's hit the pause button so you can go ahead and get caught up if you're behind. And I put Dora in a bad spot. So there's Dora, so you can get caught up on those. Okay, so now we're here. And so this is the exact same kind of problem as last time, but it's worded differently. We have to find the values so that it is a parallelogram. Well, I have 2 different things. I have opposite sides, and based on rule number 1, opposite sides should be equal. So I'm going to say 3y plus 5 equals x plus 3. There's an issue with this problem because it has a y and an x, and I do not like solving equations for y and x. So I'm going to hold on to that one and come back to it. The next one I can see is that these are diagonals. Well, if it's a parallelogram, they're supposed to be equal. So I'm going to set those 2 things equal to each other. 2x minus 8 equals x plus 10. So I'm going to solve that by subtracting x's. To get rid of a minus 8, I add 8, so I get x is 18. So in order for this to be a parallelogram, for this part of the problem, x has to be 18. Well, look at this. This problem had an x, but you just found out what x was. So I'm going to take this x and I'm going to plug it in here. So it'll be 3y plus 5 equals 18 plus 3. So I combine my terms. So I get 3y plus 5 is 21. subtract 5 and get 16. So y is 16 over 3. Not a great answer, but it works. Okay? So what I did was I started off by writing your equations. It doesn't matter which equation you start with or which one you write first, but for this one, I couldn't solve this equation without knowing what x was. So I wrote it, but then I came back to it later and I focused on this other equation. Okay? So here's the infamous Dora pause so that you can pause the video and make sure that you get all caught up. Okay, so the last type of problem, and you're going to have more of these in the chapter, this is the first one, is when we have to do things on the coordinate plane. Okay? So what we need to do is we need to graph the quadrilaterals and determine if it's a parallelogram. And if it's a parallelogram, we have to explain why. And there's several different ways you can explain why. So what I want you to do first is go ahead and graph both sets of points. So graph the points from problem A and graph the points from problem B. So here's both of them graphed. I went ahead and connected the dots, and I went around the shape so I would make a quadrilateral. You need to double check these to make sure they're right. If your points are not in the right spot, then you need to pause the video and fix them. Okay, so we have to figure out if it's a parallelogram. Well, a parallelogram has opposite sides equal, opposite angles equal, adjacent angles 180, and diagonals bisect each other. Those are all pretty hard rules. When I'm going to figure out if something's a parallelogram, I'm going to look and see if the opposite sides are parallel. I think that's the easiest way because all it is slope, and remember slope is rise over run. And then remember our little saying, parallel slopes stay the same, perpendicular flip and change. So I need to find out if my parallel slopes stayed the same. Stay the same. If they stayed the same, then it works. So on this first one, I'm going to zoom in, and I need to count this slope here and this one here. So to get from A to B, I went up 2 and over 1, 2, 3, 4, 5. So I went up 2 over 5. Now, in order for it to be a parallelogram, this has to be the same. This one I went up 2 and I went over 1, 2, 3, 4, 5. Yeah, 2 over 5, that works. But that's only one side. Remember, parallelograms, both sets of opposite sides are parallel. So now I need to check this one, so I'll highlight this one purple. So to get from A to D, I went down 1, 2, 3. And I went over 1, 2, 3. Oops, not a negative 3. Negative 3 over positive 3, which is a negative 1. Well, let's see. Did I go down 1, 2, 3 and over 1, 2, 3? I did. So these are the same. So my reasoning to know that it's a parallelogram, yes. Both sets of opposite sides have equal slopes. And the reason I'm going to say equal slopes is because if they have equal slopes, then I know they're parallel. Okay? So now you're going to do the same process with problem B. You're going to count the slope for both of them and see if the opposite slopes are the same. If they're the same, then they're parallel. If they're not the same, then they're not parallel. So here's the famous Dora pause. Go ahead and knock yourself out and try it. Okay, well, I found the slope on my pink sides to be 2 over 2, which is 1, and my slope on the orange sides to be negative 2 over 4, which is negative 1/2. They're the same on both sides, so it's a yes, and it's the same reasoning as over here. Okay. So for this section, I don't think it's really that much more difficult than last time. It's just practicing. You do need to be careful with the coordinate plane. The first thing you got to do is graph the points right. If you make a mistake on the point, then it's going to be hard to do the problems. But then you still just apply those 4 rules. Rule number 1, opposite sides are equal. Rule number 2, opposite angles are equal. Rule number 3, adjacent angles are 180. And rule number 4, diagonals bisect each other.